So thank you for coming, everybody. My name is Roger Westberg. I am the Smart Grid Segment Manager for Maxim, working very closely with both utilities, system integrators, meter manufacturers in the Smart Grid segment. So that also includes solar power and other types of renewable energy, and also distribution automation type products. And I also represent the G3 PLC Alliance. I am one of the chairs there, the WS2 chair. And so I work very closely with the Alliance to develop the standard and try to convince more utilities and customers to join the Alliance and to take advantage of this great technology. So today we wanted to talk a little bit about why fast, secure, reliable communication is so critical moving forward in the energy Internet of Things. Well, there are 4 workshops, workshop 1, 2, 3, and 4, so there are 4. Yeah. If we look at the power grid as it looks today, it's a very noisy and unsecure environment. And so this is what we are faced with as implementers, a very noisy, unsecure environment. And the goal here is to make it robust and secure. So implementers are faced with the challenge of meeting both current and future requirements while ensuring interoperability, and also make sure that there is an evolution forward into the future. And so in doing that, they have to make sure that they choose the right technology and go through these different things that we will talk about here. And some of the critical points that are important in choosing technology is, of course, cost. As we all know, everybody, and especially the utilities today, are driven by cost. Although they want to implement the best possible technology, but it has to come at a reasonable cost. And when I'm talking about cost, it's not just the cost of the communication network, but the entire infrastructure, the entire smart grid infrastructure. And of course, real-time communication requires that it can go very long distance, because as we all know, customers are spread out in very many different areas. There are rural areas where you have houses that are very far from the utility, and yet they have to be connected. And then there are environments where there might be solar panel, which generates a lot of noise through the inverters. So that requires robustness in that type of environment. And then, of course, there has to be a two-way link so that the utility and customer can talk to each other in terms of providing demand control and information back and forth. And maybe the most important factor of all in choosing a technology platform is security. The ability to protect the assets, that the utilities have made investments in. You want to make sure that hackers and bad people do not hack into the smart grid. That's the downside of having a communication network. Once you have a communication network, there is this ability of hackers potentially moving into the network and destroying the infrastructure. So ensuring strong security mechanism is probably one of the most important factors. But without interoperability, nothing will work anyway. So having interoperability where different manufacturers of meters, different technology providers, different chip solutions providers, all can talk to each other is critical, because otherwise you will have a monopoly and you can't have that. You have to have an open open standard that provides interoperability, and that's another very important factor in choosing technology. In order to meet future requirements, you have to have scalability and upgradability, so that in case of a change in the standard or the governmental restrictions or regulations, there needs to be a way to upgrade the network. And so having scalability and field upgradability is also very critical. But without strong industry support from the market, it will not be successful anyway. So you have to have many different vendors of both, meters, system integrators, as well as the utilities, all working together to ensure that this standard will be successful. So strong industry support is also very critical. Now, the G3 Alliance now have over 60 members, which is a mixture of all these different companies and utilities worldwide. So the G3 PLC was defined by utilities and developed for utilities. It all started with ERDF, which is the biggest and the only electricity distribution operator in France, with 35 million customers, looking for a technology that would offer a balance of high data rate, robustness, quality of service at a reasonable cost. So in order to meet this objective and goal, they teamed up with a technology provider, Maxim Integrated. So that's how we actually started this whole development of the G3 PLC standard. So we developed a spec. The first one was completed in 2009, and since then it became a standard in December 2013, an ITU standard called G9903. So when you look at the distribution systems operators or utilities, they have their requirements, as we all know. Now, how does that match up with the actual features of G3 PLC? So one of the requirements was that communication needs to be reliable and work in very harsh environments. So how does the G3 PLC address that concern? Well, robustness means that you have to have very good error correction. And G3 PLC actually offers 2 layers of error correction. And it always finds the best possible path or routing in the network. Another important thing is, of course, security. We talked about that earlier. What does that mean? Well, it means that you have to provide security between the meter and the data concentrator and the utility. And that is addressed with 128-bit PSK authentication and ciphering at the MAC layer. Another important thing, of course, is the ability to work in the future. So IPv6 ensures the way that this will work in the future Internet of Things, being able to bridge over to wireless if that is needed, and so on and so forth. So accommodate future applications over IPv6 is how we future-proof this technology. Multi-sourcing, of course, is very important in terms of interoperability. So G3 PLC is an open standard, international standard, as we talked about earlier. But we also need to ensure that all these vendors can work with each other. So interoperability is critical, and that is also offered and addressed in the G3 PLC standard. Installation and maintenance cost is of course a factor of the total cost. So plug and play and simplicity in terms of installing this technology is important, and that is also addressed in G3 PLC. Ability to operate in clusters from 2 to 1,500 meters and supporting and scaling up to 2,000 nodes is how we address the need for scalability. And then a way to self-reconstruct the link if the link is broken is extremely important in mesh networking, and that is also addressed in the scalability of G3 PLC. So now the question is G3 PLC the right solution for Korea? So the G3 PLC has been widely field tested around the world, and so this ensures the ability to work in very many different regions, very many different environments around the world. And here's a list of different countries that Maxim has tested G3 PLC successfully, and as you can see, it really represents the whole world. Now we are going to take a look at one example here, and that is Germany. And Vattenfall is a large utility in Germany that implemented G3 PLC in FCC band. The reason why we're bringing this up is that it also is what Korea is planning to do. They're planning to implement smart meter networking over FCC frequency band. So we're using that as an example, a good example of a successful implementation of G3 PLC. So here is a typical smart meter architecture in Germany. You can see that we have a PLC modem here. We have a smart meter gateway that provides, which is the same as a data concentrator actually, that provides the security mechanism. And then you have the smart meter that takes the measurement and passes that measurement into the gateway that then passes that information onto the PLC modem back to the utility. So Vattenfall went through several options. Senelec, of course, is a European standard, which is what ERDF in France is deploying. So when they are going to deploy G3 PLC in a large scale, it's going to be in the Senelec frequency band. The benefits of this, of course, is that it's the EN 50065 European standard, and there's a separate frequency band for the energy provider to use. Now, the minus side, or the disadvantage, if you will, is that it offers a limited data rate, but it's good enough for ERDF. But it may not be good enough in other environments where there are a lot of noise sources. Now Germany, they have the highest concentration of PV, photovoltaic or solar panel systems in the world as a percentage of the population. And solar panels are being introduced in a wide scale in very many different countries, and I'm sure here in Korea as well. So being able to work in that noise environment is critical, and that's why Vattenfall was picking FCC band, which is 150 kilohertz to 500 kilohertz band. So the Senelec A band is all the way from 3 kilohertz up to 95 kilohertz, but again, it's very limited frequency spectrum. Okay. Yeah, and that's why Vattenfall actually picked FCC because they were able to go much longer range, 1.7 kilometers, and much higher data rates, and so significantly higher data rate compared to Senelec. But wait a minute, high data rate, you say? What about broadband PLC? That's even higher data rate, right? Yes, it is. Now you're talking 1.6 megabits per second. Isn't that better? Well, the problem with this, so the answer is it's great for certain applications, such as in-home communication. So when you are in a in-home network where you want to connect internet to several devices, maybe a TV over IP or IPTV, and other entertainment devices, great. Because it's all short range. It's within your house, right? So it's not long range. But for outdoors communication, which is what we're talking about here, the power grid, you have to be able to go very long distance sometimes, definitely hundreds of meters or kilometers. This is not good enough because it will require repeaters. It will not work over maybe 30 meters, and that's why repeaters are needed in broadband PLC, which in return will be higher cost. We were talking about the importance of keeping the cost down, right? So this increases the cost for the network operators and the utilities. So that's why vendors like Devolo, for example, is providing home plug, for example, communication within the home. That's another alternative to broadband PLC. There are a lot of alternatives, of course, inside your home. Most likely, most people will be using Wi-Fi because that's the most popular. But if you want to take advantage of the power line infrastructure within the home, which is everywhere on your walls, then that's one way to communicate. But as soon as you go outside of your house, there are other issues, and that's why G3 PLC is a better choice. All right, so Vattenfall's conclusion. Oh, I'm sorry. Did you want to? Yeah, I think yeah. So Vattenfall's conclusion, after going through all these options and evaluating different technologies, was that G3 PLC and FCC band is the ideal choice. And I also think that this is the ideal choice here in Korea, if it's implemented correctly. So they were able to essentially eliminate repeaters, because they could go very far. Very good range because of the frequency band, and also much higher data rates, and fulfilling the bandwidth requirements, as we talked about. It is designed by an open standard, as we mentioned, ITU G.9903, and it is available from media manufacturers. So these are some of the factors they went through. And why am I using this as an example? You see here one of the modems from Devolo. Devolo is using technology from Maxim Integrated. So it's a very successful example of how you can implement underground power line communication, overhead line power line communication in rural areas, in high-rise buildings, in all kinds of different environments where it all works because Devolo used Maxim technology. So what is behind this technology? What is inside this beautiful white box there? Well, first of all, we're going to take a look at the trials that they took. One was in Hamburg, where Vattenfall evaluated this in a typical urban type of environment, which was a mixture of 3 to 5 story apartment complex buildings, as well as single family homes. The result was that Vattenfall was able to achieve data rates up to 60 kilobits per second net payload UDP, which was very, very good. Now, the maximum data rate that you can achieve with G3 PLC is 300 kilobits per second. So this is a very good example of how they implemented in this particular example. Now, the next phase after this is to do a mass rollout. The next goal is to do a mass deployment in difficult scenarios. So they're going to introduce some noise on the network, noise sources, bombard the communication channel with noise sources and see how that works. And so far, it has worked very well. Another example is in Berlin, where, of course, that's a big city in Germany, and that's the capital of Germany, so lots of people, mostly high-rise building. This is typical high-rise buildings, and also lots of shopping centers, commercial buildings, typical city environment, right? Mostly underground cables, which is very similar to Korea, very similar to Seoul and other big city areas. And there was also overhead lines in this particular case. Again, they achieved 60 kilobits per second data rate, which is very, very good. And the next step is to deploy in larger numbers. So Vattenfall's conclusion is that they are going to deploy in both Berlin and Hamburg. And this will act as a good example for the rest of Germany. ZENO is a product we are introducing today, Maxim Integrated, which actually provides the brains or the technology behind robust power line communication. Now, this technology was not developed overnight. It has been developed over 12 years. So when I was talking about all the field trials that we've done around the world in all those different countries, including Germany, that has been done with previous generations of chips. But the cost effectiveness of having separate chips like this is not ideal. The utilities are looking for higher integration, smaller solutions, lower power, and lower cost. And that's why we developed the MAX 79356. So this is by far the smallest and most robust and most programmable solution on the market today. Here's an example of our evaluation board that customers can take and test the technology and see how well it works out there. And it works in very many different environments and standards, and we'll talk about that. So it's a multi-band, multi-standard solution for many different frequency bands. Okay. It's really, we've actually used Greeks names for all of our products. So we have Zeus, which is a metering chip, that's a god in Greek, right? Greece. Zon, and now ZENO. So it sort of follows the same theme of Greek old gods and mythology. I just want to clarify what MAX 79356 is all about is that we have actually integrated the digital baseband, which is the PHY and the MAC, along with the analog front end, the PLC analog front end, all into one chip. And it also has DSP accelerators, as well as all the memory required to meet all these different standards that we support. So here are some of the advantages and features. Some of the most important advantage is the packet size. We're talking about a product that fits into a 48-pin LQFP, a very small package. Very cost effective, in other words. Another important factor is the power, low power. The power consumption is 70 milliwatt, typical in active mode, which is very, very low. And why is this important? Well, if you are a meter manufacturer or if you are a utility, you want your meter to consume as little power as possible. I mean, it doesn't make any sense if you're measuring power consumption from the customers if your meter itself is consuming a lot of power, right? So the motivation to bring the power consumption down for the meter is very, very important. As a matter of fact, ERDF is specifically encouraging the meter manufacturers to lower the power consumption, and that is encouraging and rewarded. Optimal network efficiency through smart routing to eliminate any unnecessary broadcasts is another great advantage of the Maxim chip. And we have separate RISC processors to handle, you know, the DSP intensive tasks of the PHY and the microcontroller intensive Mac. So a separate RISC processor for the Mac and a separate RISC processor for the PHY. And then in addition to that, we have a DSP accelerator that optimizes the performance. No need for external memory support. We have plenty of memory on board, 512 kilobytes. So we can store 2 stack images, one for execution and one for updating. So no need for external memory, which again reduces the overall bill of material cost. We talked about the importance of preventing hackers from hacking into the network. So security features are very important. So we have a built-in cryptographic module that not only provides the minimal security, which is outlined in the G3 PLC spec, which includes, you know, the 128-bit AES, but it also provides assurance into the future if there is a need 5 years from now to add more security features to stop potential threats in the future. We have the cryptographic engine available for the implementers to take advantage of. Now, the sign time to market is of course very important for system integrators and media manufacturers. And being able to provide a flexible solution that is programmable, so you can have one platform that covers all the different regions of the world, all the different frequency bands, is ideal, right? So this platform covers all the different frequency bands, Senelec, FCC, Arab, and it provides programmability with all the different standards, whether it is G3 PLC, IEEE P1901.2, G9903, Prime, whatever you like. Any OFDM standard can be implemented on this standard, on this platform, along with any frequency band on one single platform. So the manufacturers can actually use one single part number for all the different markets, which is very convenient. It makes it easier for them to manage their inventories and to address all the different markets, and it you know, makes it simpler for them to sell to different regions. Maybe you already explained the difference between G3 PLC and Prime. It sounds like it, yeah. Because you may be wondering, you know, why am I sitting here as a G3 PLC WS2 chair representative and here I'm promoting Prime? Well, the reality is that not everybody in the world are going to go after or implement G3 PLC. And that's why we, as a company, have to address even our competitors or you know, different standards. So in Spain, for example, Iberdrola, a very, very large utility, has long ago developed another standard, very similar to G3 PLC, but specifically for the Spanish market. And they've already installed 5 million modems. The difference between the two is that Prime is also an OFDM standard, but the difference is that it doesn't offer the same high data rate. It's 128 kilobits per second versus 300 kilobits per second for G3 PLC. Another difference is that G3 PLC offers more layers of error correction. Yeah, so when this gets tested in very harsh environments like you know, solar inverter noise environments, G3 PLC typically works better. Another thing that you might be wondering about is why was power line communication developed in the first place? I mean, there's plenty of wireless technologies out there, has been around for a long time, like Wi-Fi and ZigBee and RF has been around for many years, right? So why develop power line communication? Well, so in Europe, most of the meters are in hard to reach places, in basements. The infrastructure in Europe is very old, as we all know, hundreds of years, thick walls. Thick walls is not good for wireless. And wireless is not good when it comes to reaching down to basements. It's easy when you're up in, we all know that when we go down in the garage, good luck if you get a signal down there, right? With our cell phones. And that's the problem with wireless communication. So power line communication was developed to address the need for reaching to any place, anywhere. And the power line infrastructure is there everywhere, right? Because you wouldn't get your electricity unless you have the power lines. And so that's why power line communication became popular in Europe. So what we do with G3 PLC is we can pick a noise-free channel. So we have different modes, modulation modes. And through the forward error correction, we can kind of cut ourselves through the noise and then pick a noise-free channel that will work. That's really a simplified version of how this works. So the other thing that is very important, of course, is certification. The G3 Alliance has established a way to certify products in the Alliance to ensure that there's interoperability, that there's conformance to the spec, that it meets certain performance levels and expectations. So ZENO is certified for FCC band, which is the band we're talking about here. But not only that, it has achieved certification for every single frequency band and for both the meter and the data concentrator. Yes, there are other competitors in the market.
Single chip?
Yes, there's one other that covers all the different spans of the spec. The other names that I can talk about is Renesas. Okay, so now a solution is obviously not just the modem, but it also includes the meter. So the benefits of working with Maxim, and this is probably where we stand out in front of competition, is that we cover all the different bases of a smart meter system, which includes meter SoCs, or system on chips. So we have a family called ZON, which has been released last year. Very high performance meter system on chip that offers 0.1% accuracy over a very wide dynamic range, up to 5,000 to 1. And then we have a product called Zeus, which adds another core, an ARM Cortex core, that handles the higher level of stack, communication stacks, and storage. So if you combine Zeus and ZENO, you have a complete smart meter that includes the highest possible performance in terms of accuracy. We're now talking 0.1% accuracy over 10,000 to 1, which is above and beyond what any smart meter manufacturer will be looking for. But that offers additional capabilities and possibilities to do harmonics testing and potential measurements of non-intrusive load monitoring and things like that. So in addition to the ZENO PLC, we have the metering features, and this is where I think Maxim stands out in front of the rest of the pack. And the Zeus product also offers security because it has a security engine and it also has a secure boot feature. So not only do we offer security between the meter and the data concentrator or the utility, we also offer security for the IP, for the meter manufacturer, the system integrator, and we offer security in case of an in-field upgrade. We were talking about how important it is to be able to upgrade in the future. Well, that's also an opportunity for the hacker to get into the meter and hacking, but they can't do that with Zeus because we offer, you have to essentially have a key that corresponds to the internal key inside Zeus in order to get access to Zeus. So in other words, there's no access to the meter unless you go through this key exchange. And so what we offer here is a complete solution from end to end, meter to power line communication. And in addition to that, we also offer some unique isolation technology for galvanic isolation, if that is what the customer is looking for in three-phase applications. So all in all, that's the benefit of working with Maxim. We are a complete system solutions provider from meter to power line communication. And I think that's one of the unique advantages that we offer our customers today. So manufacturers today are not looking for multiple vendors to work with. They would like to work with one vendor that can offer everything they need in order to build a smart meter. So again, our mission is to provide core technologies that help solve the world's largest economic and environmental problems. How about that? And this is a picture of our headquarters. This is where I work in San Jose, California. Thank you very much.